Chapter 8.5, Annuities, Methods of Saving, and Investments. In the previous chapter, we looked at the compound interest formula that would give the future value after T years when a fixed amount of money P is deposited in an account that pays interest. However, money is usually invested in small amounts at periodic intervals. For example, to save for retirement, you might decide to place $1,000 into an IRA at the end of each year, or $50 at the end of each month. Recall in the last video where we solved for that present value to have $10,000 in a few years, we would need to deposit over $8,000 into the account. Probably if I had $8,700 right now, in 5 years I'd have the $10,000 on my own without any trouble with that. That's not how we save. We usually make smaller deposits every month. And it doesn't have to be a month, but typically we go month to month. Okay, an annuity is a sequence of equal payments made at equal time periods. And so here are our two formulas associated with annuities. Again, the A, the P, the R, the T, the N are all the same in all of our formula. And notice that this is for annual compounding, and this is everything else. So really, this is the one that we need for everything. All this is when N is 1, right? Okay, and likewise, by solving the annuity formula for P, we can determine the amount of money that should be deposited at the end of each compounding period so that an annuity has a future value of $1. Remember, when computing regular payments needed to achieve a financial goal, round the deposit made at the end of each compounding period up, no matter what that digit to the right is telling you. In this way, you won't fall slightly short of being able to meet future goals. And notice again that this is simply this formula solved for P. Okay, let's see how we can use these formula. All right, find the future value when $50 is deposited at the end of each month. This is my key that I'm talking about an annuity versus regular compound interest, because notice it uses the word compound also. So how do I choose between the regular compound interest formula or my annuity formula? Right here, periodic payments. If I keep feeding money into it over and over versus putting one lump sum in and letting it sit there. Okay, so if I'm putting periodic payments in at the end of each month into an account, paying 6% interest, compounded monthly for 30 years, find the interest earned on the account. Okay, first of all, I've got to see how much I'm going to have in my account in 30 years. And so here's our formula. Okay, A equals P 1 plus R over N to the NT minus 1 all over R over N. Okay, so let's go back and figure out what I get to plug where. Okay, $50, that's my P. Oh, it didn't change my color. Or I didn't change my color, I guess. Okay, so this is my P, right? My principal, the amount that I plug in every month. 6% interest, this is my R, and it's got to be as a decimal. Compounded monthly, so N is 12 and T is 30. So I'm just going to plug into this formula. Replace the P with 50. 1 plus 0.06 over 12 to the 12 times 30 minus 1 over 0.06 over 12. Now these brackets on your calculator, just use your parentheses again, so you'll just hit the parenthesis sign twice here. Remember, you got to have parentheses around this, and you don't necessarily have to have them around this. Your calculator knows order of operations, but usually we like to put them around there just for our own peace of mind. So I'm going to enter this formula in my calculator. Okay, so 50, parenthesis, parenthesis, 1 plus 0.06 divided by 12, close parenthesis, raised to the parenthesis, 12 times 30, close parenthesis, minus 1, close that bracket, which in our calculators just close that parenthesis, divided by, that big bar is a division symbol, okay, open parenthesis, 0.06 divided by 12. Close your parenthesis, hit enter, and we find that we're going to have $50,225, and rounding to the nearest cent, I'm going to go ahead and round it to the nearest cent. My calculator tells me 75212, so that rounds to 75 cents. Okay, but this question didn't say how much are you going to have in 30 years. If it did, there's my answer. That's how much I'm going to have in 30 years. What it asked me was, how much interest did I make? Well, in order to know the interest that I earned, I need to know how much I deposited into the account. I put $50 in the account every month, so 50 times 12, for 30 years. That's the amount of money I actually put into the account myself. So if I put that on the calculator, 50 times 12 times 30, that's $18,000. All the rest of that, above the $18,000, is interest. So 50,225 minus 18,000, that's the amount of interest that this account made for me. So $32,225.75 was interest that was earned by simply putting $50 a month into an account. Notice a good time period here, 30 years, an extra $30,000. Determine the periodic deposit required. Okay, so now I'm solving for the present value, what I have to put in today to have $200,000 in the future, right? So that means I'm going to use this formula, the one that's solved for P, solved for the present value. And it looks like this. Okay, so determine the periodic deposit required to have $200,000 in 10 years at 4.5% compounded monthly. How much of the financial goal comes from deposit and how much comes from interest? Okay, so the $200,000 is what I'm going to have in the future. That's my accumulated amount or my future value. Of course, 10 years is T and R is 0.045. And because it's compounded monthly, N is 12. So let's plug that in. And we have 200,000, 0.05 divided by 12. Okay. All over 1 plus 0.045 divided by 12 to the 12 times t is 10 minus 1. Don't forget, when you enter this in your calculator, you must have parentheses around this. You do not have to have parentheses around this top portion. Your calculator is going to multiply and then divide. But if you prefer to have an extra set of parentheses, right, you can have too few parentheses, but not too many, as long as they're in the appropriate place. Let's plug that in my calculator, see what we come up with. 200,000, parenthesis, 0.045 divided by 12, close the parenthesis, divided by, now, open parenthesis, 1 plus 0.045 divided by 12, close parenthesis, to the open parenthesis, put 12 times 10 in it and close it, minus 1, close parenthesis, hit enter. Okay, 1322, and my calculator tells me 7681, but remember, no matter what the calculator tells me, when I solve for present value, I always round up because I want to be able to meet my financial goal. So that is my periodic deposit. I have to put in 10 years, if I want $200,000 at this rate, I've got to put in a little over $1,300 a month. Then the next question is, how much of this comes from deposits and how much from interest? Same thing as before. Well, if I'm putting $1322.77 every month for 10 years, then I have physically put in $158,732.40. So all of the rest up to $200,000 is interest. So if I subtract this from 200,000, then I see that $41,267.60 is interest. Okay, and it asks how much comes from deposits and interest, so I better label this interest. And this right here is deposits. Okay, 158,732 from deposit. Okay, let's try one more. Suppose that at age 25, you decide to save for retirement by depositing $50 at the end of each month in an IRA that pays 5.5% compounded monthly. How much will you have from the IRA when you retire at age 65? How do you know which formula to choose? Yes, I see that it's compounded. The word compounded means I'm on my compound formulas. However, is it compound interest or an annuity? Because I'm depositing $50 periodically in some fixed period, it's the annuity formula. Right? Now, do I want the one solved for P or the one solved for A? How much am I going to have in the future? That's the one solved for A, the future value, the accumulated amount that you are going to have. So that's how we choose which formula to use. And we've chosen this formula. All right. Now I have to figure out what my PRN and T are. I'm depositing $50 at the end of every month, so that's my principal. That's my periodic deposit. Pays 5.5%, so that's my interest rate as a decimal, 0.055. Compounded monthly, so N is 12. And T, I have the N, the R, the P, I need the T. Well, if I'm 25 now, and I'm going to retire at 65, then that is in 40 years, right? So that's what my T is. T is 40. So if I plug those values into the appropriate places in my formula, I have 50 times 1 plus 0.055 divided by 12 to the 12 times 40 minus 1 all over 0.055 divided by 12. Don't forget your parentheses here when you enter it in your calculator. And let's see what our calculator tells us. Okay, I got $87,051.98. I hope you got the same thing. If you didn't, let me know and we'll work through it.